Right. Mechanics, velocity time, graph, and away we go. Got it? Possibly. Nah, it'll do. Alright. A train is undergoing linear motion. The table below gives its velocity at different times. With the aid of a graph, calculate the distance travelled. Okay. Yeah, we need to...
You don't need a graph.
No, it doesn't need to be...
You know the maximum height and the time and the base.
But then...
We just need to make sure it's the shape is the right shape. Okay, do you have the times written down? If I could draw maybe the graph.
2 seconds accelerate and then 2 seconds deaccelerate.
Yeah, but it goes up to 10, does it?
Yeah.
Yeah, and then at the beginning it's increasing up to...
Okay, yeah.
It increases up to 10 in 2 seconds. So it's like this at the beginning, yeah?
Yeah, and then it goes back to 0.
But it keeps the 50...
I was
Oh, no.
talking about question 2.
Oh, I know, I was looking at 1. It goes up to 15 in 3 seconds. Sorry, so that's a 15 and that's a 3. And then it keeps that for 2 seconds. So it goes to 5. Then it goes down to 10, 5, 0 at the 7th second. So that's the 7th second. So let me just double check. After 3 seconds it's hit 15 and it's still at 15 at 4.
That is wrong.
Is it? Hang on. Well, I'm clicking between the two.
1, 2. That's a 2. 4. No.
Wait. 3 it's at 15. 4 it's at 15. Okay, so at 4 it's still at 15.
Wait.
But what?
2 it's at 10.
Oh yeah, we don't care about that. Somewhere there. It's still a straight line, isn't it? It's going 0, 5, 10.
Yeah.
Yeah. So 4 is at 15. 5 back down to 10. Yeah, okay. And then at 6 it's down to 5.
7 and 0.
That's at 6, isn't it? Oh, at 7 it's 0. 8 is 0. 9 is 5. And 10 is 5. So 8 is 0. But then at 9 it's 5. And at 10 it's 10. So it must have started increasing then at 8, 9. Okay, so if I had graph paper it'd be much easier to do, but I have the right shape. Yeah. So triangle, rectangle, triangle, triangle. So a half, 3, 15. Oh no, we haven't done trapezium, we won't use it yet. Base by height plus 1, 2, 3. A half the base by the height plus a half the base by the height. Okay, a half the base by the height, base by height, a half base by height, a half base by height. Yep, okay, I think I have them all in there. A half times 3 times 15 plus 15 plus a half times 3 times 15 plus 10. 70 meters?
Yeah. 70.
Slight calculation error perhaps.
Yeah.
Yeah. Okay, so that's number 1 done, is it?
Yeah.
Right, now, number 2 is more interesting. An elevator starts at rest and accelerates up to the next floor. It accelerates for 2 seconds, then immediately decelerates for 2 seconds. Total, it travels 10. and it's a 4-second journey. So what's happening here in number 2, we have something that travels for 4 seconds. It accelerates, and then it immediately decelerates, and it accelerates for 2 seconds. So that means it must also decelerate for 2 seconds, because I tell you the total is 4, don't I? So that's a 2 there. Okay. What else do I tell you? That the total it travels is 10.
The area is 10.
The area is 10, and I want the velocity here. Actually, this is okay. A half the base by the height should equal 10. So 10 times 2 divided by 4. So V is 5 meters per second. Did you get that?
At first I did that, but then you gave us the distance and the time, so, and they were asking for speed, so I used distance point.
Wait. Oh, yeah, okay, yeah. But you're happy with this now?
Yeah.
Yeah. It's okay. Okay. And number 3.
Yeah, number 3 wasn't so good.
It was hard. Can I do number 3?
That's fine.
Yeah.
Yeah, do it now. So, number 3, I see you have a graph, that's right. The graph isn't so straight. So the time goes up to 10, and the velocity goes up to 36.
Can you go back to the previous question?
Yeah?
No, your solve.
Oh.
Yeah. You did base times width times height.
Mm-hmm. A half the base by the height equals 10.
Yes. Don't we use this one as a right triangle only?
No, can be any triangle in fact. So it works here. Yeah. Okay, can I look at 3 now? Yeah. So 0 to 10, and we have 0, 1, 4, 9, 16, 25, 36. So there's 5, there's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're going up to 36. So I'll go 10, 20, 30, 40. So it starts off at, now actually that's not meters per second, it's, you probably know it's kilometers per second. Yeah. Right, so we start off at 0, and then 1, 4, 9, well hang on, 1, 2, 3, yeah, 16, 25, and then 36, just like here. So what's happening is it's actually really curving upwards, and then it comes tumbling back down 18, 9, 4, and 0. So the next one here, it starts at 0, ends at 0, and this one here is a 4, yeah, if we're going backwards, and then the next one is a 9, and then the one before that is an 18. So then it decelerates, it tumbles back down. Plot the data, what's the maximum acceleration? So we have to think carefully where the maximum acceleration happens. Does it happen on the left half or the right half?
Left.
Has to be the left. Now is the graph getting steeper or less steep?
Steeper.
It's getting steeper. So the maximum acceleration happens during this part. So the slope here is the change in the velocities. That's 36 minus, what's the height here? 36 minus 25. And then the base is 1. So what's that, 11?
11, yeah.
So the maximum acceleration is 11 meters per second squared. Maximum deceleration Likewise, yeah, you see it there. Likewise, it's this one here. So by the same logic, it will be minus 18 meters per second squared. Oh, kilometers, thank you. Kilo.
Do you have to mention minus? If it's
No, you don't, actually, because I said deceleration in the question. And the last one's a bit hard. How far did it travel?
This is
This is hard, because the shape is not a triangle.
it's not straight.
It's not straight. But at this level and this point of the course, I only expect you to estimate it. So we'll estimate it. We'll say that it's not going to, if I draw a big triangle from here to here, here to here, will the answer be right?
No.
It'll be too big or too small?
Too big.
Too big. But let's see what we get. So the area that's too big, the big triangle, is a half the base by the height, which is 36, isn't it? So what's this, 180 or something? Yeah, it is 180. Now, of course, we all know that's way too big. So let's put a smaller, if I put a smaller triangle in, let's say from here, let's just draw it roughly to here, and here, let's just say roughly to here. How big is that base? 1, 2, 3, 4, 5. So that's about 5. So it's a half, 5 times 36, which is 90. So our shape is somewhere in the middle, isn't it? Yeah. So I'm going to say S is roughly 180 plus 90 over 2. Roughly. So I'm going to get it roughly 135 meters. Anybody close to that?
I didn't even count it. Like I tried.
No, actually, it's actually kilometers. Sorry, kilometers. Yes. With my eyes, roughly.
But how do you get the
This is not good. This is bad. I know it's bad. I just use my eyes and my feelings. And this is not the way to do it in the exam. I just wanted you to do this to practice reading with your eyes. It's important, it's very important in physics to be able to estimate values. Okay, of course you want to be exact, but estimating is an important skill as well. So I just estimate it. Now I can give you the exact answer, but I won't tell you how, that's later. Not that. We're getting closer, yeah. Now just think a second.
You need an equation.
That's right, don't worry, I know everything. That's okay.
I wanted to do that, but I'm like, not worth.
I got half of that answer.
Okay.
How you can count for every second?
Hang on, let me think. Don't confuse me. It's halving on the way down from 36. So what's that? 36 minus... It's actually not really so curved at the end. It's a bit more of a straight line because it goes 18, 9, 4 and 0. Let me think.
I was thinking of dividing it into like triangles.
That was it taking a while.
Yeah.
Yeah, what I was thinking, in Excel you can break it up into pieces like this. Is that what you mean?
Yeah.
Maybe I'll do that actually. Maybe I'll do that in Excel. Will I? Maybe. Just give me, you know what? Let's do this in Excel. I want to show you the graph in Excel. Because then I can show you Excel's graph. It'll be much neater than mine, and we can get to the more exact answer here. Loading. Here we go. Right, so I just need you to, in a moment, once it comes up, give me the numbers. So I know the time goes from 0 to 10, doesn't it?
Yeah.
Yeah. Is it seconds, right?
Yeah.
Yeah, okay. So we have time in seconds, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the velocities in kilometers per second. So the first one, 0?
0,
Yeah.
0,
Yeah.
and then 1.
0, 0?
1.
Oh yeah. 1, 4, 9, 16, 25, 36, 18, 9. No, something went wrong.
Yeah, that's right.
4, is it?
Yeah.
0.
Oh, 0. Okay, so I'll make the graph for you.
But they can draw straight line graph.
Straight or curved, it can do both. I'll keep it as a straight line for the moment. So we have x-axis is time in seconds, y-axis velocity in kilometers per second. So this is the graph that you should have. Did you get something similar when you drew it?
Yeah.
Yeah, now I can have Excel calculate the area exactly. Because what I can do is I can calculate it for each second. You know. So I'll just do it roughly. Okay. Let's see if it's close. Yeah, not too bad. 122, and I got 135. Not too bad. Not too bad. I never said it was going to be perfect, but we're in the right area. It's not like I got 500 or something. So this isn't really an exam question. It's just more about practicing using graphs. Okay. All right. That was the last one of the homework. So we'll continue on then.